and welcome to this webcast that will be for the next hour or so. Not only SQL or NoSQL for the SQL Server Professional and for the DBA. So thanks for joining me. We're going to have a demo-filled hour or so, and I also encourage you to ask questions as we go. I will try to answer as many questions during the presentation, and if I don't get to them, I'll stay on until the end. So we have lots of information to cover, so we're going to go ahead and get started. So I am a data professional working mostly with relational data for over 12 years. I have an expertise particularly working with SQL Server, both relational and non-relational technologies. Up until recently, I was working at Microsoft as a developer evangelist. I left in October of last year to return to private consulting. And it was interesting in my last year or so at Microsoft, I started working with the cloud teams on the data side, and that led me to this kind of realization. You can take a look at this and read this. As we all well are aware of, probably why you're joining, NoSQL has become a hot topic these days. So the question first is why? Why do we care about it? And then what should we do about it and how should we proceed? So I'm hoping to give you some good, useful information in this webcast about these topics. So let's start with the why for NoSQL. Why are those of us that have worked for years as DBAs and RDBMS developers are we now interested in NoSQL? And what I'm seeing out there in the data horizon is this this word that we're hearing a lot, big data. So what does that mean? What is the practical implementation? And what it means is there's a data explosion. There's exponentially more data that we are dealing with. And where I'm seeing this manifest itself in different industries is through what I call behavioral data. So I'll give an example, a specific example out of retail, which is an industry that I've done quite a bit of data work in. So up until relatively recently, most of our retail environments, whether they're online or bricks and mortar, would collect transactional data. So that's kind of shown at the bottom of this graph. So this represents a visit to a mall, if you will. So they would collect and store in a relational database purchases and maybe locations and stores where you were at. What is new on the horizon, and I happen to live and work in Southern California, and there's been a really sort of a dramatic increase. I know that some of the malls out here started collecting this data back in Thanksgiving of last year, is the collection of what's called behavioral data. And it comes in different ways, but an example that I'm actually very familiar with is data coming out of phones. So what this is meant to represent is that now the phone providers are making, in this case, mall stores and malls available to purchase data about where customers were, what they did on their phone, what searches they did, so on and so forth. And how this is resulting in opportunities for us data professionals is retailers. And I'll give a very specific example, such as Nordstrom or Target or just some of the stores I shop in. They might be very interested if I'm shopping, let's say, for a pair of black boots in Nordstrom in a particular mall, what else I might be doing on my phone. If I might be looking for a different size of boots, if I might be price comparing, if I might be looking up on an online boot site, because maybe I don't end up buying because they don't have the boots that I actually want. And in the sort of old pre-big data days, they would only capture whether I bought or not. They would not capture what I was doing and what could cause me to buy. So it's probably an oversimplified example, but it's one that I'm actually working with. And you can see here the data that's being collected is exponentially more. So another way to think about this is big data is this sort of next state or future state or possibility questions, whereas traditional data is transactional. This happened. This occurred. Big data is often, but not always, behavioral. What could happen? What didn't happen? What is the possibility of happening? What do we think could happen? What is probabilistically going to happen? Another industry that I've been personally doing some work in is manufacturing. As the price of sensors comes down and more sensors can be installed on manufacturing lines, I've got some customers that have actually come to me and said, now we have all this log data, but it's just exponentially huge, and we don't really want to buy more servers, get more, RDBMS licenses, and we also don't know how to look at it. So what should we do with this data? We want to do something with it. So sort of the high-level trend that's driving this is the pervasiveness of behavioral data, the cheapness of sensors. Another thing I was looking at, because I'm trying to get more fit, as a lot of us are doing, is I'm looking at fitness sensors, whether they're the activity bands. I know Nike has a new one that I'm looking at. Fitbit, of course, is huge. And now I've even seen that there's some startups in Silicon Valley that are embedding sensors in clothing, which seems kind of interesting to me, depending on the price. So the concept here is that as data professionals, we have to now figure out how to deal with exponentially more data that is, I guess for lack of a better word, more junky. We may not want to keep all of it. For example, going back to my Nordstrom example, when I'm in Nordstrom and I'm shopping for those boots, Nordstrom is probably interested in what other kinds of shoes I'm shopping for. They may or may not be interested in what movie I'm looking at on my phone later on. They might, because maybe they want to cross-advertise there. But the point is, as it relates to transactional data, which generally the businesses want to have 100% integrity on, behavioral data has a percentage of usefulness, which again affects how much companies are willing to pay for the storage. So why should we change? Aren't our SQL Server and our Oracle and our MySQL databases working just fine? Why should we change? Well, this goes to traditional database theory. This is called the CAP theorem. So that the concept is that data stores can serve up 2, but not 3, of these capabilities. So the first is consistency. So it means transactional consistency. So this would be our world of SQL Server and Oracle. We have no transactional integrity problems. And this is sometimes, often, a business requirement. Availability. We have to have 100% uptime. We can never be down. It has to be interactive. We're doing e-commerce. If we're down, we're out of business. So there are certain types of databases that are consistent and available. But they fall down when it comes to massive scaling, because they are not designed for massive. When I talk about massive, I mean massive, multiple terabytes, petabytes. They just fall down at that level. And that is really where we're hitting the wall with the relational systems, because they are not only expensive, more expensive than some of the non-relational systems most often, but they also do not scale as well. So the sort of darling of the big data trend, if you will, is Hadoop. So you probably heard the word Hadoop. Big data, Hadoop, and NoSQL are the 3 hot words basically in the database realm. So really the question then is NoSQL Hadoop? Is it the same thing? Is that what it means? And the reality of the answer is no. Hadoop is a type of data store, but the hype factor around Hadoop, especially over this last year and a half or so, has been intense. It's been really interesting. I've been attending some data summits, the Strata conferences and the Data Scientist Summit put on by O'Reilly, and just this intense sort of frenzy of interest. And up in Silicon Valley, too, some work that I've done around using Hadoop, whether there's a good business case or not. One of the reasons I'm taking the time to do webcasts and talks around this topic is sometimes the hype factor is really challenging for us data professionals, because our bosses hear this Hadoop and NoSQL, and they think that with not enough information that that's the way that they want to go. And it definitely has some functionality in some data solutions, but not all. So what is Hadoop? Where does it come from? It basically comes from Google. It's their own sort of implementation of their file system, and it's designed to work with massive amounts of data. It has become an open source framework, and it's what I call a big data bucket. So we're actually going to look at some of these NoSQL technologies in this talk, so you can get your head around what they look like with various vendor implementations. Of course, Hadoop being open source, there are many different implementations of it. You can go and download it as open source and set it up on Linux. Microsoft has also done a port. I don't know if it's available yet. It was a private beta last time I checked. It's called Isotope. It actually runs on Windows. So There's all kinds of different implementations of Hadoop. The point, though, of this is Hadoop is not the only solution. And just to follow on this idea of Hadoop is the hot thing, what we saw last year around the time of SQL Pass is both Oracle and Microsoft came out with connectors between their RDBMS systems and Hadoop, which caused me to take note because neither of Oracle nor Microsoft is known for playing well with the open source community. So this was obviously being driven by demand. So these connectors that shipped last year, and they allow data interchange between these big RDBMSs and Hadoop systems. So if you are to work with Hadoop, it's going to take you a little bit of time to understand the technologies if you're coming from an RDBMS background. I'm working through the process myself. You know, like I said, I've been out back in the wild since October, and I've been prolifically blogging and screencasting and sharing my learning to try to help the community so that you can benefit from the hours that I've spent on this. I am starting also to implement with live customers. I've been working actually with some startups. So not so much with enterprise, although I have one enterprise client I'm working with now, to take a look at this. And you'll see this is a Cloudera, which is a vendor that creates tools for Hadoop on the sort of non-Microsoft side. And this is a summary of some of the tools and technologies that work with Hadoop. At the very bottom, you have the Hadoop file system, and then you have your catalog for metadata. You have HBase, which allows a table-like structure to be put over the top of the data store. And then you have some higher level utilities, most notably MapReduce. Again, you may have heard of MapReduce. This is a framework for working with the data stored in Hadoop. So kind of your query mechanism, if you will. And then we have, even on top of that, some higher level utilities called Pig. Yeah, it's really called Pig, and it's kind of like an ETL. Actually, funny, the command prompt for Pig is called grunt, and it responds with oink when it's working well, which is just kind of funny. Anyway, and then we have Hive, which is a SQL-like query language for these table structures. So those are sort of the core things. I've listed over to the side. Most commonly, you will write your MapReduce jobs in Java, although as we'll see in some implementations, notably Microsoft, there's some other languages that you can use, which is interesting. And on the bottom of the slide, you'll notice that I have some other technologies. I think it's called Mahout, which is an analysis framework. And then you have some other frameworks that are graphical, overlaid. Karmasphere is an Amazon implementation. And then another thing that you'll hear is R, which is the statistical analysis language that's used with big data in general, and more and more coming to be used with Hadoop. So I've been talking about all these high-level esoteric things. It probably would be good if we can start looking at different vendors' implementations so that you can kind of get your head around what this actually looks like. Now, one of the things I'm going to show is currently a closed private beta from Microsoft. This is called Hadoop on Azure. So this is Hadoop on the Azure cloud. And I'll be working with a web browser to show you how this works. I've been fortunate to be invited to be part of the beta, and I've been doing, again, quite a bit of writing and work with it. I did speak with the team, and the beta is still very limited. So at this point, I don't think they're adding anyone to the beta, but I've made a lot of screencasts. So if you want to see more about this, this deck is already up on SlideShare, and I have the linked YouTubes. So I'm going to go ahead and just show you a couple things. So let's start. So I went ahead and signed into Hadoop on Azure, and I have already allocated my cluster. So when you initially sign in, you have a URL addressable cluster of Hadoop nodes, if you will. So you'll have what's called a name node or a head node, and then you'll have child nodes. And you pick from 4 predefined implementations that has a certain amount of compute and a certain amount of storage space and so on and so forth. You'll see that the cluster during the beta it automatically expires, and then you can refresh it if you need it. Then you can see if I scroll down here, we have Metro style interface, because of course it's Microsoft. And what you work with in Hadoop is you process the data through these MapReduce jobs. So you can see here I've got a button to create a job, and then I have some jobs that I have tried out. If I scroll down, I have some administrative capability in my cluster, and then I have some account management. One sort of good thing is if you do get on this beta, it is let me go ahead and sign in here. It is actually free, which is really nice. I haven't had any charges at all. So I'll click here and see we're not billing. So, but on the same hand, this is a beta, so I do not know what the pricing will be, nor when this will be released. So some of the things that you'd want to do here is you'd want to open up ports if you want to communicate with FTP, get some data here through FTP, or you can actually communicate through Excel, which is sort of interesting. If you want to do more sophisticated port configuration, then you need to go through RDP. And in addition to working with this interface, you can work with RDP. Now, the simplest possible thing you do here is you would work with one of these samples. And the easiest one to work with is word count, which basically takes some body, it's like a book basically, and it runs a map and a reduce job so that it will count the number of words by a word occurrence, just to give you a sense of how this massive parallel batch processing in Hadoop will work. Now there's some other samples in here that you can look at, but this is the simplest possible one. So that's pretty well documented. So it says count the number of occurrences of each word in notebooks of Leonardo da Vinci. So it tells you exactly what to do. So you have to get the text file, and you can work with this in regular Java. You can work with this in JavaScript, which I'll show you in a minute, which is kind of interesting. But first you have to get the file. So you get the file, and you either upload it to your Hadoop cluster through this console, or you go to FTP. And again, the instructions are pretty good here. And then you run the job. And then you look at the output. It produces an output file. And this is just showing you all this good stuff. Now, if I click Deploy to Cluster, then I get this interactive job running window, basically. So it says, here's the job, here's the jar file, which is the Java file, and I could replace this with my own. So if I wanted to, try out my own implementation, I could do that. And then I've got a couple parameters for this job. So it says, okay, what am I doing? So I'm running a word count. And then where does the data come from? And then this is what the command looks like when you'd run it. Now, one thing that's kind of interesting here is by default it's looking for this location on your instance. But another sort of interesting implementation here is that you can use a connection to S3. So this is Amazon S3. You can use a connection to Windows Azure Tables or your HDFS drive. So you can use any of those. And then when you're ready to go, you just click Execute Job, and then you'd see job history. So when you're working in the world of Hadoop, what you're doing is you're massively parallelly processing these big data sets like logs or text files or whatever generally. And then you are taking those results and then working with them further. Now, a business example of this that I think is kind of interesting is the social data ranking site called Clout. Again, I have this on my stream on YouTube. Now, Microsoft did a video on it, but a business case, what they basically do with this is they collect all these different logs, people's Twitter activity, Facebook activity, blogging, so on and so forth, because they want to rank your power socially, basically. They also collect what you do on the cloud side. And then they use Hadoop to make sense of this data, to basically consolidate and aggregate it, and then they pass it to another store. Now, in their case, they pass it to an OLAP cube, which is interesting. I think more of the customers probably would pass it to a relational store, but they actually pass it to an OLAP cube, and actually they're updating it to use the new BISM model in SQL 2012. But in any case, it gives you kind of an idea of the interactivity between these big data buckets, whether it's Hadoop or some of the other ones we're going to talk about, and the relational stores. So one thing that's very unique to Microsoft's implementation that I want to point out is they have an RDP, which this would just give you RDP, so you could run. Well, I can just run it really quick, I think. And this just gives you direct access to the head node. So if you're a Hadoop professional, if any of you guys are already working in Hadoop, maybe in some other environment, you can just use the CLR, the command line interface, And you can see here we are right just inside of our session. And there's a couple of utilities in here. So you can leverage your Hadoop knowledge. So yeah, that's cool. And there's, here's your MapReduce job tracker thing. So a website, I guess you'd call it. And the whole thing with Hadoop is you're running these jobs and you want to make sure that they're going to be successful. So, and you can see here we've got some job, and I don't think I've run any jobs recently, but you can see if I can do this here. It will talk about, basically what's going on with your jobs, and then you can look at your job tracker history, which it comes either way. Basically, it comes on the desktop, or it comes in the portal, and this is your Hadoop command shell. So you can, work directly if you're comfortable there. So you can do that, and so let me log off of here. And one thing that so the remote desktop is not unique, but it's another piece of functionality. A thing that is unique is the interactive console. So you can use Hive, but you can also use JavaScript. So this is very unique to Microsoft and very interesting. I've been actually writing a little bit about it because it allows those of us who come from the .NET world who maybe don't know Java as well to leverage JavaScript. So interesting JavaScript console. We also have a Hive console here where we can have interactivity. And again, just interesting in the implementation. Now, just for the purposes of completeness, these guys, Microsoft's out with this. It's interesting. It's appealing to me, but obviously I don't know the pricing and the performance. I would be remiss if I didn't talk about sort of the big guy in town, which is Amazon. So Amazon has Elastic MapReduce, and this has been out for a really long time. So if you are wanting to take a look at this kind of functionality, you can try this out. I think they have a free tier, although I'm not sure for MapReduce. So basically it's the same type of functionality. This is Hadoop running on their cloud. So you've got upload data to your S3 bucket, and then you create a MapReduce job and then get results. So I would recommend that you take a look at this as well, because this is also an excellent implementation. There certainly are many, many more. I tend towards the Microsoft side of things because I have that background. But I also think it's very important when we're looking at cloud solutions to look at Amazon. Okay. So that gives you a little bit of idea of what that looks like. So as I was saying, really when we're thinking about NoSQL, there's two pivots. The first pivot is, do I need to use NoSQL? Do I have data that will work better in that format? And then which version of NoSQL, which we'll get into in just a minute. And then the second thing is, should that NoSQL be on-premise or should it be cloud-hosted? The argument for cloud-hosted is there's so many implementations that are already set up. And especially if you're going to set up on Linux and you're not familiar, it's not an easy task to learn all that. So you need to take that into account. Also, it can be more that you can have less concerns over the maintenance and all that good stuff if you go for cloud. I do realize that for some of you it will be a better solution to host your NoSQL on-premise, and that is something you also can consider. So those are the two pivots. So now, kind of drilling into the NoSQL, there are over 120 different types of NoSQL databases, and I could have, like a 5-day seminar on them. So what I did for the purposes of this talk is I really am going to focus on Hadoop and then a couple of others. So I really liked this. I found this out on a blog. It's referenced there, and I actually changed it a little bit. There's, many discussions about what NoSQL is, but I tried to distill it into something you could actually use. And this is the way that I look at it when I talk to customers. So basically there's databases that are what are called graph-based. That's a picture of it, and we'll look at an example in just a minute. Column-based, document-based, and key-value-based. So the big sort of thing to think about is these are not relational. There is no concept of joins between tables. So it's different structures for individual tables. So now, that being said, let's start with graph. This is the one, frankly, I'm least familiar with. Here are a couple of examples. The idea of it is you have recursive self-joins. And I've read about like social network sites that use this to establish connections between the information in the social network logs or whatever. So Neo4j seems to be the big popular one. And then there is a cloud open source graph database that's supported by Google that allows community sharing of data. That's been something I've looked at and played with called Freebase. So I've read about the use of this in social network sites, but frankly I have not used it myself. Column databases is the world of Hadoop. So there's, Hadoop, Google File System, MapReduce, Bigtable, and Pig and Hive sitting on top. They have all these other internal names. Basically, it's wide, sparse column sets. So you have a key, and then you can just put as much into the column as you want. Cassandra is another one that I hear quite a bit of use, especially in startups. And Windows Azure Tables. So let's take a look at Windows Azure Tables. So, inside of here, I'm in Microsoft Windows Azure, and their implementation is under Windows Azure Tables. And you can see here I have a storage account. One of the things that I have to say about this is that the tooling doesn't really help you very much. You can, right-click and set up the account, or add an account, I guess. New storage account will give you a name, and then it gives you the endpoint. But other than that, you can't really see what's in it or work with it or anything. So I would recommend, unless you want to always programmatically access this, that you get a third-party tool. The one that I use is from Nudesic. It's the Azure Storage Explorer, and it's handy. So you can upload, download, look at stuff. Just easy to work with. So it's for blobs, queues, and tables. And it's free. This is on Codeplex. So when you are trying this stuff out, I would recommend you get some kind of tool, because it just saves you quite a bit of time. I know that Microsoft has changed their pricing to correct some of the issues they had with their free tier. I had some issues before I left, which I blogged about. This is a new free account that I've set up, and so far, knock on wood, I haven't had any issues. So good for that. Also in the world of column databases, we have some Amazon offerings as well, which I'll come back to. So another area, and one that I've actually been doing some production work in, is document databases. And I've been working with something called MongoDB. MongoDB has really been a delight. And this is a document-oriented, a collection of JSON documents, semi-structured, so you can have things in XML, so on and so forth. They internally use what's called BSON, which is Binary Serialized Object Notation. CouchDB is another one, and you can see what this looks like. Now, I have been working with this with some startups with some really good success for working with documents. One of the things that I found in working with Mongo, which I have to show you, this is the entire installation, which quote-unquote isn't really an installation. You just download it, and then you set up this config file, which takes like 2 minutes. Now you can put more stuff in it, but basically you just put the path. There's really great documentation on the Tengen site, really, really, really good. But what you would normally do is you'd work with this command line, and I'm just not as productive with the command line. So I searched around, and there's many different tools, but the one that I really like is MongoView. There's a free version that has most of the functionality, but it was like $35 to buy it. And what I thought was just really terrific is that I could go like this, and I could say import and import from relational, which was really helpful to me. Very, very worth the $35. Now I realize not everybody's going to be moving data from relational into NoSQL, but I think many of us on this call probably have more experience with relational than NoSQL, so it's been very helpful with my learning. So simple to set up. The concepts here is you have your server, you have databases, and then notice my little tongue-in-cheek, not AdventureWorks. You don't have tables, but you have collections. So collection is basically a table. And you can see I've pulled these over from AdventureWorks. I just imported them because they still have the schema name there. And then inside of here, inside of a collection, every collection has an ID field by default. And then we can go and we can look at the collections. And we can have a tree view, and notice there's a shell down here, which is just a nice feature, which helps us to learn the query language, which is different because we're not going to get T-SQL or anything here because this isn't like relational. And you can see the key, there's the ID, there's the information. Again, these people really are understanding, I think, what we're up against. We have a table view, even though this thing's not a table. And then here's what it actually looks like, the JSON view, which is really, really fantastic. So I've loved this tool. I've used it quite a bit. I'm actually working on a project now where I worked with a startup, and they used a relational database in the cloud. Well, actually, they used SQL Azure to be specific. And they found that it didn't really meet their needs. So they wanted to go to a NoSQL solution for scalability and for they weren't really able to predict what the schema would be because it's a brand new sort of concept. So the schema-less or schema-light environment was really something they needed. So what I'm actually doing is I'm working side by side with them, and I'm ripping and replacing out the relational connectivity, and I'm replacing it with Mongo. So I'm actually going to be blogging about that as we go along. It's been a fun project. But this gives you, I would really recommend if you're getting into this world and you come from RDBMS background, that you get some good tools because it helps. Notice in here we have MapReduce, so the mapper and the reducer. So that comes into the Mongo world as well. So this concept of learning MapReduce is really quite important. So then we have also key value databases. Okay, now this might be a little bit confusing as to how this is different than a column database. And really it's actually simple. As it says here, column databases, you can just throw anything in the non-key column. And key value is just a key and a value, a key and a value. So it doesn't have the sparseness, I guess, if you will. Sort of the new guy in town is Amazon's DynamoDB. So let's jump out and take a look at that. That was released recently. And what's exciting about this, among other things, is DynamoDB runs on all solid-state disks. So it is claimed to be super fast. Now, I have not done production work with DynamoDB yet. I'm looking forward to the business case that will warrant it. But just to show you kind of how it works, as it says, it's a fully managed relational database service that provides fast and predictable performance with seamless scalability. So what do you want to do? You want to create a table. And if you don't know how to do that, then you just go through this little thing. So we'll actually create a table, and we'll call this, what should we call it? What day is it today? I'll just call it Demo for DM. And then you pick your, as it tells you it's schemaless, you just say the primary key. So you're going to say if it's a hash in range, a string, or a number. And then it says hash attribute. Choose the hash attribute that ensures your workload is evenly distributed. Here's an example, customer ID. It's a good one. By game ID, it might not be good. So we'll just go with customer ID. We won't fight City Hall here. And obviously, you can learn more about it. I'm just doing this quickly so you can get a sense of it. Provisioned throughput capacity. How much throughput? Well, if you have no idea, then you can have them kind of run some metrics and figure this out. Because if you're like me, the new world of NoSQL has got some very different metrics you may not know. Or you can just say, well, let's just start with 5 and 5. Because again, figuring out the pricing here is not the simplest thing because we're pricing not based on what we, RDBMS, DBAs that worked with on-premise SQL and Oracle know, which is licensing and server costs. We're working with throughput. It's like buying electricity or something. So let's just go with our 5 and say continue. And then we have alarms. So notify me when the table's request exceeds 80%, and then send it to me. So create. And we are done. We have created our table. So new world, very different stuff. Dynamically scalable, running on SSD, and we can just dump stuff in there. I'm real interested to work with this in a production situation, but it's so new and different. I'm having a struggle figuring out what the actual pricing will be, and of course customers are a little hesitant to buy it when they don't know how much it will cost. So I've got my eyes out for case studies and things where I can help say with a little bit more authority how much things might cost for my customers. So anyway, back to the world of NoSQL. So hopefully through this I've convinced you that it's not just Hadoop. So in the classic world, where most of us come from, we need consistency and availability. So we'll have things like SQL Server, SQL Azure maybe, Oracle, MySQL. They might be on-premise or on the cloud. Some of us might have a business situation where we have to deal with this behavioral, this log data, and we have to run MapReduces across it on a regular basis. And that we might be more interested in consistency and partitioning. And if a node goes down, we'll just put another one in. So that would be Hadoop, or some of the solutions out there from some of the other vendors. On availability and partitioning, but what's called eventual consistency, you've got things like DynamoDB, CouchDB, Cassandra, and Voldemort. So lots of different choices. Again, to help us to understand, because frankly, although it's not only Hadoop, for many of us, we will start by considering Hadoop. I pulled this summary out from Tom White, as you can see, and I made a couple of changes based on just some stuff I've gone over. So traditional RDBMS, we work with gigabytes up to terabytes, but when we go beyond that, we start looking at something like Hadoop, petabytes, hexabytes, whatever huge bytes are. This is very important. Traditional RDBMS, the access is interactive and batch. Hadoop is not designed to be interactive. You can kick off a MapReduce job and then you can go home, because it might take hours. So although there are certain things you can do, obviously, to performance tune to make those MapReduce jobs be run faster, that the concept is to process massive amounts of data in parallel, and be able to come up with a result eventually, but not immediately necessarily. Again, updating, traditional RDBMS, read, write many times. Hadoop, write once, read many times. Batch update. Structure, traditional is static, Hadoop is dynamic. Integrity, ACID, so atomistic, consistent, all that good stuff. Hadoop is base, which is eventually consistent, if I remember correctly. Scaling, the traditional RDBMS is nonlinear. You reach limits. Hadoop is linear. Query response time can be near immediate, can be. Hadoop was going to have latency, though. So again, hopefully that sort of helps you. As we're understanding how we'd use it and who uses it, you can see these are all the big social network cases. And you can see this actually comes straight out of Wikipedia, all these use cases. So Facebook runs on a combination of Hadoop and MySQL. Twitter runs on Hadoop. You ran on a number of different things before. Yahoo runs on Hadoop, and I think SQL Server, actually. LinkedIn runs on Hadoop and Voldemort, I guess. Cloud runs on Hadoop, HBase, and SQL Server. So you see this sort of combination of Hadoop as the huge bucket, and then some sort of relational solution kind of stuck on the front for the aggregated data, or maybe for the transactional data. So this is not the only use case, but it's one that is out there and very sort of prominent. So again, a lot of us that come from RDBMS, transactional data, we are not really excited about the cloud because we feel like we might lose control. We might incur these expenses we don't understand. So why would we want the cloud, and why would we want the cloud for NoSQL? Why wouldn't we just stick with what we've got? Well, one of the biggest forces driving this move towards NoSQL in general, and NoSQL in the cloud in particular, is it's dramatically cheaper. When I left Microsoft last October, I can see this is dated November 9th, I did as thorough as I could have, a little comparison between relational storage in the cloud and non-relational. And I think I did 100 gigs. I can't remember. It's out there on that blog post. And I tried to compare as best as possible, which, of course, as you well know, is difficult because the vendors don't make the pricing comparison easy, because one place you have to say the instance size, the next place you have to say the data transfer size, and I did the best I could. But what it came out with was that relational cloud storage was 50 times more expensive than non-relational. So that shocked me. Obviously I had been more on the corporate side before I came back out into the real world, and so I wasn't focusing as much as I maybe should have been on pricing. I knew there was a price difference, but when I was going to come out and consult, I thought I better find out how much the price difference really is. And I was stunned by how different the pricing was. And this may have changed a bit. I know SQL Azure came and reduced their pricing dramatically. They were 100 times more expensive at the highest level when I wrote this, which is good. Competition is good for the customers. But this is driving the movement of data towards NoSQL. Now, it's kind of illusory because, yes, the actual storage is cheaper, but one of the costs associated with working with NoSQL is understanding from a technical standpoint both how to develop against it and how to administer and maintain or contain costs. And as those of you who are listening in, if you've tried to struggle with this at all, it is a big question mark for a lot of us who come from RDBMS because it's a totally different world. So yeah, the storage might be 50% cheaper, but how much more hours in personnel and staff and how much longer does it take you to write MapReduce jobs versus just writing a T-SQL query? All these things are costs as well. So as I've been porting this project for the startup from SQL Azure, because the team went with SQL Azure because of familiar tooling and because of the ability to do T-SQL, and when they hit some limits and they wanted to move to Mongo, one of the things that we're exploring is how much does it cost in development time to write queries in languages that you're new to versus T-SQL. We're actually timing so that we can get some benchmarks and some sense of this because we think it's information people will want. So now let's look again, just be complete at some of the other vendor implementations around NoSQL. The very sort of the bottom level, of course, we've got the blob buckets. Now these are used for many different reasons. These can be used for personal storage, and everybody's got them. They are all the rage, it seems, all the vendors. But you can also develop against them. So sort of the first, lowest, simplest level of NoSQL, if you're going in the cloud, is the bucket. And Amazon is the gold standard. So if you don't have S3, you should get S3. It's the standard by which all others are judged. Works great, good price, super easy to work with, super easy to program against. Not free, but good price. And if you are using this for any production situation, a very good piece of advice that I heard from a guy from the TDWI group was putting data across 2 different cloud vendors, because all the big vendors have had outages, Google, Amazon, and Microsoft. And this guy put his data in Amazon and Rackspace, and I thought that was a very, very good idea that I'm going to at least recommend to customers. Hard sell sometimes because, again, it increases the cost, but one of the ways you can leverage against outages that you may or may not have control is to go across multiple vendors. Anyway, I would always start with S3. That's just the gold standard. Now Google, which I haven't mentioned at all, has been doing some interesting stuff. Of course, they have Google App Engine, which I guess I should mention a little bit. I didn't talk too much about it because it's very wired together at this point. I've done some development on Google App Engine, and this is the dashboard. And you can see that they do have a NoSQL data store. It's called the High Replication Data Store. It's very much an implementation of their own technology, so it's very specific to Google, and it takes a little bit of time to learn. So this just shows this is their, it's called kind, which is an entity, basically, and then you can look at an entity and you can drill in. It's just their viewer, just to give you an idea of what storing data looks like. So they've got different data types, geospatial points, so on and so forth. They also have, this is kind of fun to look at. Let me go back. We have, some of you might know that I do work with teaching kids programming, and we created an endpoint for our kids stuff, and we put the output up on blobs on App Engine, which has been sort of fun. So we can actually see when kids are programming. Just another implementation, kind of a fun thing. Had a recent event here, and we can see when what the kids do after the event. Well, that's kind of an interesting, cool thing. Love to see what kids do. Anyway, so the thing about this is that right now it is tied to, you can't program against it separately. You have to use Google's front-end stuff, which if you're using it, great. But I'm focusing on data storage here. So if you happen to be using Google's front-end stuff, then you can use their back-end. But it's not like Windows, Azure, or Amazon where it's just completely independent. So another thing that Google has these days is they have, and I'm not sure if this is released or in beta or whatever, because I'm beta for so many different companies. They have cloud storage, which is their bucket. Let me reload this. This is under their APIs. So cloud storage, let me go to the storage manager. And see, it looks like Amazon S3 basically, so that's their cloud storage. And then they have cloud relational. So a lot of people didn't even know they had this. So again, I have my little tongue-in-cheek. It's MySQL hosted on their infrastructure. So you can see how that works. And then they have a little SQL prompt, and you can work with their stuff. But the challenge with their stuff is you've got to use their front end right now, and it's Java or Python. So again, if that's your world, then it's a viable option. They have a great developer story. I've had 0 charges. I can try it out. Great little sandbox. So it's definitely got some merit. Depends on sort of where you come from. The HR data store, there's a lot of good some intro stuff on it on Google I/O Talks, and I've done some blogs. It's definitely its own little thing. So the dev time there, if you come from anywhere but Google, takes a good amount of time, and that's something to be considered. But it auto scales, so that's a good thing. So what else do we have? Of course, we have Dropbox and Box, and then they came out with Google Drive as well. So all these things are sort of the NoSQL. So then I'm starting to show you the cloud-hosted RDBMS. So I showed you Google Cloud, lowest cost. It has pretty limited RDBMS functionality. I guess you could connect with MySQL toolset. I'm not a big MySQL person, so maybe I'm a little biased there. I prefer SQL Server. So if I'm going to have a cloud-hosted RDBMS, I prefer SQL Server. So up until recently, my preferred world was SQL Azure, which we all know SQL Azure, and it has a lot of good functionality, but it doesn't have quite everything for various reasons, and it has some sort of proprietary things. So it doesn't have backup and restore. It doesn't have profiler. It doesn't have a lot of tools that I like. But that was what we had. An exciting thing, and I know this is a NoSQL webcast, but I want to be complete, is Amazon has just come out with RDS for SQL Server, which is really exciting, literally a week or so ago. And I'm basically all over it for anything that I'm going to do relational in the cloud, because you spin up an instance if you want it. There's my little instance. And they have a free tier, so you can try it out. So you say launch, and you can see the free tier is Express. Right now it's 2008, and then you have different all the way up to Enterprise, which is new, but they've announced they're going to support 2012 as well. So I'm super excited about this. I have to kind of get my head around the pricing, but from a tooling standpoint, I just have to show you this because it's super exciting. So here I've got in Management Studio, I have SQL Azure. And you can see that we got some pretty restricted stuff here. So like, for example, if I wanted to, I don't know, do a database diagram or something, I couldn't do that. I'll just connect to something relational just to give you a sense of this. So, and it's pretty restricted functionality. Just a lot of things aren't there, right? Can't back up and restore and stuff. But here I'm connected to Amazon Cloud inside of Management Studio. So like, let's say I wanted to, I don't know, import or something. I can just, any of the stuff that I'm used to doing, I can do it inside of here. So I can create a new database. I can use Profiler. I can't run backups on my schedule. When you set up your SQL instance, you have to say, and Amazon will set the backups, test for DM. But I am really liking this. I made a little webcast about it because I was super impressed. So really, to me, it's just a question of if the cost is right. I'm tending probably to go more towards Amazon because it's more full tool support. Although, the vendors are in heavy competition, so things do change. So like I can, make a database diagram, which is sort of cool, which I can't do that with SQL Azure because I like my database diagrams. I like my tools. So I have to, let me go ahead, and then I could, add my tables, so on and so forth. There's just a lot of stuff here. Like if I right-click here, you can see I have a lot more stuff than if I go here and right-click. And I realize there's different business reasons for this, but I'm just going to say, as a developer, this is going to make me more productive. So I thought I'd show you guys. So all right. There's a bunch of other types of cloud data services out there, too, that are interesting to look at. There's this concept of public data sets, and you can use them to get information, just generally read information. You can use them to improve the quality of your information. SQL 2012 has this thing called data quality services, and you can use public data sets from like the Windows Azure data market, or just some general ones, like there's InfoChimps and stuff to do, for example, address validation. It's kind of an ETL. Other than that, I should probably show you the Windows Azure data market here as well. So let me just do that if you've not seen it. Other than using that information, you can also host information. So if your company has some information you'd like to put out there and charge for access to it, you can do that. So it's a trend that I would encourage you to take a look at if you haven't seen it yet. So you can see inside of here I've got my data, and I'm using the free stuff basically, but for example, I use this digital trowel, which is I'm using it at the free level to demonstrate data quality services. So you can see how much costs there, and I can just explore this data set. I can integrate with data quality services, and it's just, again, it's another interesting trend as we are working with large amounts of data up in the cloud. Another set of tools that are interesting is ETL tools. I've listed down 2 from Microsoft and Google. Data Explorer, which is basically like an SSIS but created for business people or subject matter experts, kind of looks like Excel. And there's Google Refine, which is similar conceptually. There are also some integrated cloud vendors. Splunk is one of them I've looked at, that will upload your logs and provide analysis and actually give you the output as a visualized chart. So different types of cloud data services as you're getting into working with all this data. I may have a screen on it. I can't remember. There's another one called Karmasphere, I think I mentioned, that does MapReduce jobs visually. So if you don't, it's on Amazon. So if you don't want to, they charge for it. If you don't want to learn how to write MapReduce code, you can put your data there. So again, as we're getting into this new world, you need to figure out how to hold the data, where to hold it, on-prem, which sort of format, and then how to process the data. So this kind of gives a summary of what I've found, that you have, for cloud RDBMS, you have, and I just put the big 3. I think Rackspace definitely deserves listing here, just the amount of people that use it. Then NoSQL buckets, the Azure tables here as well, and NoSQL databases, streaming machine learning. I didn't really get into that too much. Document graph databases, Hadoop, and then data sets and other. So there's a lot of activity here, a lot of activity. So what do? You basically have to say, all right, am I going to use NoSQL? Which one? So I'm going to use the big bucket, Hadoop, or am I going to use something that has some sort of structure like a graph database or a document database? Am I going to host it locally, or am I going to host it in the cloud? Then am I going to have an RDBMS component? Are they going to interop? Can I have separate data, locally, cloud, a mix? And then I'm going to use any other services. One other interesting sort of provider that I've been looking at, because people ask me, like, where should they host Mongo, for example, which I don't really have a great answer. Probably some of you on the phone know more than I do about this, because I've been just working with it on-prem. But I've been hearing good things and looking at App Harbor. App Harbor, it looks like it sits on top of EC2 on Amazon. And you create an application, and then you have these add-ons. And I just started playing with this, but you can see that, like, if you go to the database section here, that they do a lot of this setup work for you. They work with, looks like, other third-party vendors where they have, Mongo here, They have some other types of databases, and they have different levels of usage. Sort of the big trend, obviously, is that you are buying, again, like you buy electricity, or like you buy, internet access from your house. You're buying speed, you're buying capacity. So very different way to work with data, and then you pick either relational or non-relational. So this is the world that we're in. So I'm trying to get out ahead and learn myself and share with all of you to help you so that we can make good decisions for our businesses. So that does leave what about us? There's good old Brent Ozer, one of my favorite database professionals in the world. Great blog. So if you don't RSS his blog, you should. He's got a great team. And there's DBA Survivor, and by a good friend of mine, Tom LaRock. It's kind of good to read. So how does our work translate? What things that we did in RDBMS, how does it translate into NoSQL? So some things translate directly, and some things don't. So for example, join tables together, we don't have that in NoSQL. We have to deal with MapReduce. So we're going to either have to learn Java at the sort of lowest level, or some language that works with our database system, or get some GUI tool that will do it for us. So how might that work? Well, one way that we can do it is we can do it with Excel if we have Hadoop. This is an interesting thing, and I'll show you on the portal here as this is launching. So here on the portal in the downloads, there are, it wants to time out. There's a Hive provider, which has an add-in for Excel. So you can see here it is, the Hive ODBC setup. And once you have that, once Excel launches, has to be 2010, I think, then you get a little button that allows you to work through Excel. And this isn't the only implementation. Like I said, Karmosphere's got something on Amazon. But I mean, this is sort of a trend that you have this graphical information. Well, this is just going to cook. I'll come back to it. The concept is that we need to have this group of people now called data scientists. That basically is a group of people that are going to deal with all this non-relational data. And in the O'Reilly conferences and publications, there's been a lot of good information about. They actually have the data science starter toolkit for, I think, $150, which is some books and stuff that I've been reading. And it's around statistics, as it says, math, and it is a set of skills that many of us that come from RDBMS can easily learn. I'm living proof, and it's very valuable. So if you're trying to figure out, like from a career standpoint, where you want to move into, I'd highly recommend this. I've been going to the R user group, the Hadoop user group, the Mongo user group in LA, and there is just not enough people that know this stuff. Mongo user group last month had 100 people, and only 3 were on Mongo. So there was this really strong desire, which translates, of course, into good career possibilities. Same thing with the R user group. There were like 5 companies looking for jobs. I thought this was really interesting. Again, I have a background in linguistics, so when a different language comes along, it's just a translation challenge for me. So this is from Rick Osborne's blog. I thought it was just really, really interesting how he compared a SQL query. I know it's a little hard to read, but you can pull my deck, to a MapReduce job. And I said, you know what, I can do that. I see how that works. Obviously, there's a learning curve, but it's something I'm working on and trying to document the amount of time it takes. Here is that Karmosphere Studio, so you can see that you've got Hive on an Apache Hadoop, and you've got your query, and you're running a MapReduce. So you can play around with that if you're wanting to learn. There is what the Hadoop connector looks like. Let's see if that actually even came up. We go to Data and Hive pane, and there's the Hive pane over here, if you can see it. And then you have your connection, and then your cluster details, and your Hive objects, your tables, your columns, so on and so forth, and you get a Hive query, and you just see the data right inside Excel, which is pretty cool. Again, I made a video on it, so running short on time, so you can just watch the video. So since we are running short on time, a couple things to take away here. So what do you need to do? You're an RDBMS professional, lots of information. What do you need to do? Basically 3 things. You need to try to get your head around this CAP theorem, capacity, availability, and partitioning, and translate that into business requirements. So when do you need transactionally consistent? When do you need massive scalability? And start matching that to the different kinds of NoSQL databases. Don't use NoSQL just because it's trendy. I have had to tell customers, no, don't do it. Business people who are well-meaning, who see the information that NoSQL is so much cheaper and think they can just switch everything to it. You get what you pay for. And if you need transactional integrity, then you need to stay with RDBMS. Now, you might move that to the cloud for various reasons, or part of it, or you might not. I'd say try out NoSQL in the cloud first because it's quick and cheap. I tell people personally they should get some data up there just to work with it. If you're not doing your personal backups up in the cloud, I would recommend that you do that. It's also great for dev, test, and training environments. I've run training classes from Amazon instances, and it's just it's a great thing to do. So get your head around it, work with it, and then figure out what NoSQL access technology you want to learn. Do you want to learn MapReduce? You want to learn R? There's a thing in Microsoft called infer.net that you can check out if you're want to code in .net. Do you want to use some of these new tools, Google Refine, Data Explorer from Microsoft? Try them out. Try them out. You can follow my blog because I'm following all the stuff, and kind of pick your vendor and go from there. So understand CAP, the types of the databases, use them when they're appropriate, try out NoSQL in the cloud, and learn NoSQL access technologies. And this is really what I see, that like it or not, NoSQL is coming. May not always look like this, but this is the landscape that I see. And I want to be working in the data world, and so I feel like I need to adjust and add to my RDBMS tool set. And I like to share as I go along, and hopefully you found this to be useful. A couple things to close out, and then I'll check the question queue. In addition to doing all the data stuff, I'm the co-founder of a 501c3 teaching kids programming. And check it out. It's for kids ages 10 and up. All the courseware is free and online. Happy to say that we now are starting to publish our lessons in Java as well as Small Basic. So if you want to learn Java yourself, you can start there. We're going to translate the whole library and write more courseware all summer. So try it out. We need to teach our kids. So here's more about me. Follow me at Lynn Langit, RSS my blog. I'm teaching classes for Developmentor on SQL Server and SQL BI, so you can check that out. Also, I'm starting to teach some classes on NoSQL, so watch my blog for that. So we are at the top of the hour, and I'm going to go ahead and look at the question queue and work on some of the questions if there are any. Now would be a great time. If not, thank you for listening. All right, looks like there are no questions, so thank you again. This is Lynn Langit, more at www.lynnlangit.com, and keep making your data solutions great. Thank you.